Let us understand what is center of mass and stability. The stability depends on your center of mass. Now, center of mass is not a new term that you are hearing for the first time. You know it already, but will understand the technical reasons why and how the center of mass works, right? So in this chapter, we'll be talking about some of the things which are listed here. So one of the things that we learn is to understand and describe the center of mass. So first we'll understand why center of mass is what it is, why it behaves in such a way. We know that center of mass is the point through which the entire weight of the object acts downwards. But why? Why does it happen that way? Then we'll be talking about suspended equilibrium. Suspended equilibrium means something which is suspended. Suspended means hanging. So this object, if it is hanging like this, I can hang it through a pen. This is suspended. So if I disturb it, it moves, but ultimately it comes to an equilibrium, something like this, right? So we'll be talking about suspended equilibrium, which relates to your center of mass. Then we'll be talking about, the last point we'll be talking about in this video will be stability. If structures are not stable, they'll topple and fall down. If your chair is not designed in a stable manner, people sitting on it will keep falling, right? So we'll be talking about stability, and do please check out the next video, which is on the exam style questions. We'll be working out, we'll taking questions from your past paper exams, and then we'll be solving them to understand this topic very nicely. So let us start with understanding what is the center of mass. Center of mass, the definition of it, many of you all know it already. One of the very easy topics of physics, as we all know, and one of the very fun topic, right? Center of mass is that single point through which the resultant weight of the object acts. If you look at this picture, right, you have a ruler. So on a ruler as well, you can find one single point through which the entire weight, you can say, is acting downwards. That one point is called your center of mass. So if we are talking about this point here, let me use a contrast color. So this black point here around which I am making a circle, this is your center of mass. Please do remember that center of mass, what is that? Center of mass is a point, right? Center of mass is a point through which the entire or the resultant weight of any object acts downwards, right? Or else we can also talk about center of mass as every object behaves as if its mass, entire mass, was concentrated at one point, and this point is called the center of mass. Another name for center of mass is center of gravity. You can read both the statements again and again, they mean precisely the same. Second point talks about in terms of mass. The first point talks in terms of weight. Mass and weight, they are linked together by an equation. If you do not understand mass and weight, please go to my video on mass and weight to understand this. So from this definition, we have understood the center of mass is nothing but it is a point, right? It is nothing but a point through which the entire weight of the object seems to be acting from, right? So why it seems like the entire weight is acting from the center of mass? Let us understand about it. So look at what is happening here. As you all have understood, what is happening in the picture? You have taken a ruler, right? You have tried to hang this ruler through a piece of thread. So if you want to hang it in such a way that ultimately the ruler rests in a perfect horizontal position, you'll have to move this particular knot to and fro ultimately to find the position from which, if you hang it, the rod or this ruler will hang in a perfect horizontal position, which is said to be equilibrium, right? Right now this ruler is in equilibrium. You have found the center of mass by trial and error. By trial and error, you have found this point here, through which if you tie the knot on the thread, the ruler is perfectly horizontal. You have found the center of mass. So why the center of mass acts this way? Let us understand this. The beam is made up of a lot of tiny particles, each with a small gravitational force on it. So what is the beam made up of? This entire body of the beam is made up of millions, trillions, and zillions of atoms, right? And each of these atoms, each of these small particles is experiencing the gravitational force. Do you agree with this? So this is what is shown in the next picture. So what do you see here? Here they are showing some of the atoms, some of the counted number of atoms on this rod which are experiencing the downward force. All right, each one of the atoms, each one of the particle is experiencing a downward force. But the beam, when suspended from a particular point, say G, it balances. So why does it balance? So one concept more we have understood, that each of the atom is experiencing a downward force, right? But when we subtend from G only, that the beam or this ruler stays horizontal. Why? Why so? If you go through the chapter on moments, you'll understand from the principle of moments, that what is happening here, the anti-clockwise moment and the clockwise moment of these tiny gravitational forces about G, they cancel out. They are cancelling out. If you sum up all the anti-clockwise moments and if you sum up all the clockwise moments, they are equal and opposite. They are cancelling out. The blue color forces, the blue line here represents all the anti-clockwise moment. It is equal and opposite to the green clockwise moment. They are cancelling out, so therefore the rod is in equilibrium. And the point G is called the center of mass. Now point G is a special point. We have found a special point around which this special phenomena happens. So what is special about this point G? This is a point around which the anti-clockwise moment and the clockwise moment from the other side, anti-clockwise moment from one side and clockwise moment from the other side, they balance out each other. That's something special about the center of mass, right? Now another question arises, why do we say that the weight acts from the center of mass? Why do we say that the weight acts from the center of mass? If you look at the ruler here at the top, there are so many weights acting from the so many tiny atoms or the particles of the ruler. But why do we say that the weight is acting from the center of mass? Why? Let us understand. What is the resultant moment here? What is the resultant moment? Resultant moment from each of these forces that you see here, because clockwise and anti-clockwise, they are cancelling each other, so the resultant moment is 0. Same phenomena happens with the weight as well if we assume that it is acting from the center of mass. The resultant moment here as well is 0, because the formula for moment is force times distance. What is the force here? Force is your weight. And how much is the distance from the pivot? Where is the pivot? This is your pivot. The center of mass is your pivot. So how much is the distance? 0. The resultant moment is 0. So therefore, center of mass is a special point around which the anti-clockwise moment and clockwise moment, they cancel out. The resultant moment is zero, which is same as saying that the weight is acting from the center of mass. Why? Because the distance from the pivot becomes zero. The resultant moment is zero. Both the things, picture 1 and picture 2, are saying the same thing. What are they saying? Resultant moment is zero. Either you say it in terms of tiny particles, clockwise, anti-clockwise, cancelling out each other, or you say it in the second way, which is that the resultant weight is acting from the center of mass, which is also same as resultant moment being zero. Right? So that is why we can say that G is the point through which the resultant gravitational force or the weight acts in the downward direction. So now I hope today you have understood why the center of mass is called the center of mass. The technical reason behind it. The technical reason behind it comes from your understanding of moments, right? So center of mass is that special point on any object around which the clockwise and anti-clockwise moments of the object are cancelling out each other. Therefore, the object stays at equilibrium when it is held from the center of mass, right? The same thing you can say that the resultant weight is acting from the center of mass, which is also same as saying that the resultant moment is zero. The resultant turning effect is zero, which means the object is not turning, it is in equilibrium. Simple and straightforward, right? If you have any further doubts, you can just comment in the chat box and I'll try and clarify each one of your doubts. So let us now understand how to find the center of mass. The center of mass of symmetrical object is easy to find. The objects which are symmetrical means you can find the lines of symmetry. Lines of symmetry are the lines around which the object is identical, right? This is something that you have done in maths. If the object has one or more lines of symmetry, its center of mass is where the axes of symmetry meet. So what are the lines of symmetry? So here if you see at the rectangle, this is your line of symmetry. Let me use a contrast color. So sorry. So this is your line of symmetry, because if you fold this rectangle around this line of symmetry, both the figures will overlap. Line of symmetry is also an easy topic in maths, right? So this rectangle also has this other line of symmetry. So what is the point of intersection? Point of intersection is your center of mass. This is your equilateral triangle. Equilateral triangle is a special triangle where there exists the line of symmetry. So for equilateral triangle, it is easy to find the center of mass. But for other triangles which are not symmetrical, then you'll have to use different techniques for finding the center of mass. Now here is a technique for finding the center of mass of asymmetrical object. You can do this experiment at home, right? So we are talking about 2D object here. We are not talking 2D, 3D, because 3D will be very complex. So we are talking about some 2D shaped objects. So you can just cut a piece of cardboard in a random shape. So if you look at the picture, this cardboard is of random shape. Take a punch and make some holes, some 2 or 3 holes you can make around at the corner. You can choose any 2 or 3 corners. Take a punch and make some holes. The hole should be big enough, right? Not so tight and small. So that's why I'm talking about punch. Now hang this piece of cardboard that you have cut through a nail somewhere in the wall, or you can find an arrangement somewhere through a nail which easily passes through the hole. There should be not so much of a friction or tightness. A nail or a pin which easily passes through the hole, so that it is the plank or this cardboard pieces is easy to hang, right? Leave the cardboard, right? Let it come to a stationary position. Take a plumb line. This is your plumb line. You can create a plumb line as well in your home. Take a piece of thread. Take a piece of thread and tie it with a piece of stone. So take a thread like this and tie it with a stone. When you hold the plumb line, this is your plumb line, done. If you hold it from the top, if you hold the thread from the top, this thread will become perfectly horizontal, perfectly vertical. It becomes perfectly vertical. So that's your plumb line. Take the plumb line, tie it around the nail, right? And draw a line, trace a line on the cardboard along the line of the plumb line. Now hang the cardboard through another punch hole. Through the nail again you hang the plumb line, mark the horizontal, mark the vertical line. Again, I'm making this mistake again. So make the vertical line again along the thread of the plumb line. Now hang this cardboard again to the third point, right? You'll find that all these lines will be intersecting at one point. This is called your center of mass. You found the center of mass. You can try balancing the card on the tip of your pen, or you can try it balancing on the tip of your finger by keeping it from the center of mass, by making the center of mass touching your finger, right? You'll see that the card will balance. So this is the beauty of center of mass, and that's the process of finding the center of mass for irregular objects. Let us move on and understand a few more things. Let us understand suspended equilibrium. Suspended equilibrium means, suspend means to hang. Say that I am hanging this clip through my pen. I give it a push. Ultimately, it will come to a rest. If you see, it has come to a rest, right? It has come to a rest. So this is called your suspended equilibrium. The same thing you see in the picture here as well. So what is happening? You have a flower basket which is hanging from a point. You give it a push around. You can give it a push any which ways, but ultimately in picture B you see that you have given it a push. When you remove the pushing force, it will go to and fro for some time, but ultimately come to a resting place as it is shown in the picture A. So let us see what is written on the slide and understand. If you suspend an object and release it, it will come to rest with its center of mass directly below the point of suspension. So they are saying when it comes to the rest, the center of mass is directly below the point of suspension. Where is the point of suspension? This is your point of suspension. Where is the center of mass? It is directly below the point of suspension. This is what this first point is talking about. Let us read again. If you suspend an object and release it, it will come to rest. It will come to rest as in picture A with its center of mass. Look at the center of mass, this black dot, directly below. It is directly below the point of suspension. The object is then in equilibrium. Why is this in equilibrium? Why is the object in equilibrium in picture A but not in picture B? Think about it. In the meantime, I'll clear my screen with all the pen marks. Think about it. Why is there equilibrium in picture A but not in picture B? Why? Think in terms of moments. Moment of a force that you see on the picture. What is the moment in picture A? What is the moment in picture B? I'm giving you some hints as well. Okay, so let us understand the reason behind it. Its weight does not have a turning effect on the object. The moment of the force is 0. This is what we are talking about. The object is then in equilibrium in picture A. Why? Because its weight does not have a turning effect on the object. The moment of the weight is 0. Why? Let us identify the pivot. If you have to calculate the moment, the first thing that you find out is the pivot. So this is your pivot. Where is the force? You have identified the force. Force is your weight, right? Weight is a force. If you have to calculate moment, moment is force times distance. Force is done, first part is done. Second part, find the distance. How much is the distance of this force from the pivot? Perpendicular distance. Please do remember, in the formula for moment, it says force multiplied by its perpendicular distance from the pivot. So you extend the force vector backward. You're allowed to make dotted lines and extend the vector. So if you see, the force vector is lying on the pivot. The perpendicular distance between the pivot and the weight is 0. Perpendicular distance. The formula for moment talks about the perpendicular distance. We see that the weight is directly passing through the pivot. So therefore the moment is 0. Moment is same as turning effect. Turning effect. So what do you say? That the turning effect is 0. Turning effect is 0 means no turning happening. No turning happening means it is in equilibrium, right? Whereas if you look at the picture B, is the moment 0? Is the moment 0? Let us understand this. You have identified the force. For finding the moment, let me solve this with a different color pen. For finding the moment, you need force times distance. In picture B, you have identified the force, it is the weight. And how much is the distance? Extend the vector backwards as a dotted line. Where is the pivot? This is your pivot. So this is your distance. You have identified the distance. And this is not equal to 0. So therefore there is a turning effect. This is not equal to 0. So that means there is a turning effect. There is a turning effect means the object will turn. If the object is turning, moving and rotating, that means it is not in equilibrium. It is not in equilibrium, right? This is all about your suspended equilibrium. If you want the object to be in equilibrium, our object which is suspended, its center of mass should be directly below the pivot. So we are talking about 2 points. Pivot. All you have to do is to identify pivot. Pivot is a point. Identify where is the pivot, right? Pivot is a point. So mark the pivot. Center of mass is also a point. Identify the center of mass and look at their locations. If they are in the same perfect vertical line, if they are lying on the same vertical line, there is equilibrium. There is equilibrium. If they are not on the same line, that means it is not in equilibrium. All you have to do is to identify the 2 points. First pivot, second your center of mass. I hope it should make sense. If it does not, go through the solved example video of it, right? Stability, easy thing to understand. So let us start with understanding that you have a rectangle, a yellow rectangle which is standing on the floor, right? The box is in equilibrium. Why? Because it is at rest. If you look at the forces as well, the weight is cancelling out with the upthrust, equal and opposite force. The force on it are balanced, so there is no turning effect. It is at rest. If you give it a push slightly, with a small tilt, the forces will turn the box back into its original position. If you give it a small tilt, if you just give it a small tilt and remove your finger, it will again stand back. So what they are talking about, the box will again stand back. The box will again stand. If you're giving it a very small push, they are saying that if you're giving it a small push and removing the push, it will again stand. Give it a push. If this is your box, give it a small push, it will stand back. But if you give it a large push, it will topple. Second picture is about a large push, it will topple. So let me write the information that we are trying to understand here. So in the picture here, we are giving a small push. Small push. The object will rebound and it will stand back. In this picture, you are giving a large push. What is the difference between the two pictures? What is the difference? What is the difference? Try to identify the difference. Identify the difference between the two pictures. The difference lies here in the center of mass. If you look at the center of mass is inside the boundary. It is inside of the boundary. If you look at the second picture, it has moved outside the boundary. It has moved outside the edge. Center of mass, if you draw imaginary line, it has gone outside the edge of the box, therefore it will fall down. So if your push is small such that the center of mass stays inside the boundary, it will not topple. Whereas if the center of mass will move outside the boundary, it has moved outside, it will topple. So here, this is a basic understanding about stability. This is a rectangular object standing. If I push it slightly, say the center of mass has not gone outside its boundary, it will rebound. If you give it a large push, the center of mass has gone outside its boundary. It will fall down. Now let us look at the last picture. What is special about the last picture? It is a smaller box. So to increase the stability, what you can also do? A box with a wider base and a lower center of mass can be tilted further before it falls. So if you want to increase the stability, you have to bring down the center of mass and you have to make the base wider. So this we'll understand in the next slide as well. To increase the stability, if you see, the center of mass has gone down. It is lower. It is at a lower height, right? As well as the base is broader. If the base is broader and if the height is less, the center of mass or the stability increases. This is the point that we are trying to explain here. I'll explain it again. The two factors that increases the stability are make the base wider, lower the center of mass. These are the two factors which increases the stability. Let us look at the three flower vases. Let's call them vase 1, 2 and 3. Which one is the most stable? Which one is the most stable? If you say vase 1, you are right. Why? Because let us mark their center of masses. It would be somewhere here. Center of mass for 2 would be somewhere here. Center of mass for 3 would be somewhere here. Right? So let us understand the first point. Make the base wider. Which one has the widest base? First one has the widest base. Compare its base with the base of the other two. The first one has the widest base. And which one has the lowest center of mass? The first vase has the lowest center of mass. So toppling it, turning it around, making it fall will be the most difficult. Vase 1 is the most stable, right? So this is about your stability. Stability is also a very easy topic to understand. This chapter is fun to solve. The questions on it are also very straightforward. Alright, so let us take this example. Tractor safety. Will it topple? If you look at the tractor here, it is tilted. Now look at the picture, will it topple? Look at the weight. Look at the center of mass. Let me use a contrast color, some other color, maybe blue. Look at the center of mass. It is inside the boundary. It is inside both the boundaries. So it is not going to topple. Let us understand and read the point. It will not topple. It doesn't topple as long as the line of the action of its weight is within its wheel's base. It will topple if the line of action of the weight is outside the wheel's base. If the center of mass moves somewhere here so that it is outside the boundary, it will then topple and fall down. So that's how falling happens. Let us look at the picture here, the bus test. The photo shows how much a double-decker bus can tilt without toppling over. So which bus do you think is going to topple over? Let's call them picture 1 or bus 1 and bus 2. If you are saying bus 2, you are right, because the center of mass, if you see, it has gone outside the boundary. The center of mass has gone outside. It has gone outside. Right? Such tests are important to check. Such tests are important to check the safety of the bus, especially when they go around bends and hilly roads. So if you see, this is a factory setup. In the factories, they are testing the toppling of the bus, how much it can be tilted before it topples down. So such tests are very, very important by the manufacturers of the bus. Why? Because if they want to launch their models in the market, they need to get approval from the government to do so. So if they are complying with the standards, then only they get the license from the government to do the mass manufacturing of their model and sell them in the market. Otherwise, they will not be allowed. So there are some safety standards that the bus manufacturers need to comply with. Alright, so the next video will be on the exam style question. Please go through it to understand all the technical bits about this very interesting and very straightforward and easy topic.